In this video, we will talk about physical quantities, and we'll define then units for these physical quantities. So there are different ranges of objects in the universe. Some are small, some are straight, some are huge. For example, the size of a universe is very big, and the size of an atom is very small. The amount of time for the decay of an atom is very small. Then we have the age of the universe, which is very large, very large amount of time. Time is large. So we can write these different quantities in quantitatively. So expressing these physical quantities, we can express these physical quantities in terms of time, length, and by mass. So anything that can be measured, for example, if I can measure time, length, and mass, those measurable quantities are known as physical quantities. An example we just gave is time, length, and mass. Then we can express the relationship between the time and length and mass, and we can derive some other quantities from these physical quantities. Those quantities are known as derived quantities. So the quantities from where we can derive other quantities are known as fundamental quantities. For example, time is a fundamental quantity, length is a fundamental quantity. Similarly, mass is the fundamental quantity. Then derived quantities we have here is a force. I can express force in terms of mass and acceleration. Then I can express acceleration. Here mass is a fundamental quantity, acceleration is again derived quantity. I can express this acceleration in meter and time, so meter per second square. So those quantities are known as fundamental quantities. The units in which we express these fundamental quantities are known as fundamental units. For example, time, we have second, S for time, we have a kg for mass, and then we have meter for length. These are also known as SI units because we can express these fundamental quantities, these ones, in international units, which are called as system international. And second, kg and mass. For mass, kg, time for second, and meter for length. These are expressed in system international units. Then we can define second here, fundamental quantities. Fundamental quantities. Let me just get a new here page. So then here we define first the second. So what is a second? Second is the duration of a time of 9,192,631,770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of cesium-133 atom. This is the time duration for this much periods of the radiation of a cesium atom. Whereas a 1 meter is the distance traveled by the light in a vacuum in 1 divided by 299,792,458 seconds. So let's say if we flash a light here and it travels a distance, some distance in this amount of time, then that distance will be equal to 1 meter. So the distance traveled in this much of time. Similarly, we can define a kg. Kg is the mass of platinum and iridium. Iridium cylinder kept in an old meter standard at International Bureau of Weights and Measures in Paris. So these second, meter, kg are SI units, and these are also the fundamental units, or then we can call these quantities as fundamental quantities. We can also convert these fundamental quantities, fundamental units, in other units. For example, we have for a length a meter. I can convert this meter into kilometer, and we know 1 kilometer, 1 km is equal to 1000 meters. Then if I have a 2 km, this will be 2000 meters.